for the explanation of step 1, the step 1 says that two atomic orbital have same energy or nearby same energy for formation of molecular orbital. This is the condition for formation of molecular orbital. Two atomic orbital have same energy or nearby same energy. This is the explanation of step 1. What is the explanation? The two atomic orbital are considered, one s and another is 1s. The two atomic orbital are denoted by one is psi 1 and another is psi 2. Due to always atomic orbital are denoted psi. Two atomic orbital, so one is psi 1 and another is psi 2. Two atomic orbital, if two atomic orbital are take part in the reaction, then the how many molecules of molecular orbital is formation? Two molecular orbital is formation. The number of atomic orbital take part in a reaction, then the how many number of molecular orbital formation? Same number of molecular orbital formation followed by atomic orbital. In this reaction, two atomic orbital are take part in the reaction, so molecular orbital also formation of two atomic molecular orbital. If three atomic orbital can take part in the reaction, then molecular orbital also form three molecular orbital. The energy level, next point, the energy will depends on the principal quantum number. In a atomic orbital, energy depend only principal quantum number. The depending factor, that is, if principal quantum number directly proportional to energy of atomic orbital. If principal quantum number value increases, then what is the meaning of directly proportional to? If principal quantum number value is increases, then the atomic energy of the atomic orbital also increases. If principal quantum number is decreases, then energy of atomic orbital also decreases. That means direct relation. We consider 1s, two atomic orbital. These two atomic orbital have principal quantum number 1. What is the principal quantum number? The S subshell, before the S subshell, the number is called principal quantum number. Then next one is the principal quantum number 1. So in these two atomic orbital, principal quantum number are same. So if the principal quantum number are same, then energy of the orbital also same due to this relation. This is the relation. So the 1s and the another 1s, two atomic orbital have same energy. So this is the favorable condition for formation of molecular orbital. But you consider two atomic orbital, one is 1s and another orbital is 2s. Then the energy level depends on the principal quantum number. If principal quantum number value increases, then atomic orbital energy also increases. Between the 1s and 2s, which atomic orbital have highest principal quantum number? 2s orbital, due to the principal quantum number 2, but in 1s orbital principal quantum number 1. So the principal quantum number higher value is 2s, so more energy in 2s orbital. So the two atomic orbitals have some energy different of energy levels. There are no same energy. So this condition is not favorable for, cannot form MO. So this is the not favorable condition of formation of molecular orbital. Molecular orbital formation always same quantum number of atomic orbital. Different quantum number of atomic orbital not favor the formation of molecular orbital. Next, step 2 explanation. What is the step 2? What is the step 2? Step 2 is symmetrical atomic structure, atomic orbital, symmetrical atomic orbital favorable for formation of molecular orbital, MO. MO means molecular orbital. What is the explanation of symmetrical molecular orbital? With respect to molecular axis, with respect to molecular axis. Explanation. Step 2. What is the symmetry? That means for the favorable of for the formation of molecular orbital symmetry means 1s atomic orbital overlap with 1s atomic orbital, then form molecular orbital, then form MO molecular orbital. 2s atomic orbital overlap with only 2s orbital, that means same symmetry means same type of atomic orbital can form the molecular orbital, but 2s atomic orbital overlap with 1s atomic orbital, this is not symmetry. 2s or 1s not symmetry structure, so do not form MO, do not form molecular orbital. So this is the main point. The symmetry means, what is the symmetry? The two atomic orbital have same shape, 1s shape and 1s shape and size are equal. Symmetry means same size and same shape. This is the symmetry. 1s, 2 are 1s and 1s, two atomic orbital are same shape is spherical shape and their size are equal. 1s, same quantum number, same quantum, if the principal quantum number are same, then their size also same. Then 1s are equal size and equal shape is spherical shape and size is same. Then 2s and 2s, this is the symmetry. Two atomic orbitals are equal principal quantum number, so its shape also same. Shape S subshell always shape spherical, but the two principal quantum number value also same, then the size also same. But in case of 2s and 1s, the atomic orbital of 2s have greater size than 1s. Size order 2s greater than 1s, but shape is same. The shape name is spherical shape. S subshell shape always spherical shape. Shape is same, but size are different. Size depends on principal quantum number. Principal quantum number highest value in 2s orbital. This is the principal quantum number. So if the principal quantum number value is high, then the size of the this is not symmetry. This is not symmetrical structure. Not symmetry. So it cannot form spherical. So it cannot form a molecular orbital. This is the explanation of step 2. Then the types of, next topic is the types of molecular orbital. Types of molecular orbital. Types of molecular orbital. There are 4 types of molecular orbital. Number 1, sigma molecular orbital. Or bonding molecular orbital, or bonding MO, bonding molecular orbital. Number 2, sigma star molecular orbital, or alternative name anti-bonding molecular orbital. Anti-bonding M.O. Next, pi molecular orbital, or an alternative name bonding M.O. Last is pi star molecular orbital, or alternative name is anti-bonding molecular orbital. Star sign denoted anti-bonding molecular orbital. Star sign denoted by anti-bonding M.O. Without star sign denoted bonding M.O. bonding molecular orbital. So this is the types of molecular orbital: sigma molecular orbital or bonding molecular orbital, sigma star molecular orbital or anti-bonding molecular orbital, pi molecular orbital or bonding molecular orbital, pi star molecular orbital or anti-bonding molecular orbital. Star sign denoted anti-bonding molecular orbital, without star sign bonding molecular orbital. This is the types of molecular orbital. Then the how it is formation: sigma molecular orbital or bonding molecular orbital, how it is formed. This is first I discussed. First, sigma molecular orbital. Sigma molecular orbital. We consider sigma molecular orbital, how it is formed. How it is formed. I consider two atomic orbital, one is and another orbital is atomic orbital. This is atomic orbital, SPDF. This is the atomic orbital. 1s plus 1s. Two atomic orbitals. One atomic orbital denoted psi 1 and another is psi 2. Two atomic orbital. Formation of symmetry, also symmetries. Then the two atomic orbital, formation of molecular orbital. How many molecular orbital? If in a reaction take part in the number of atomic orbital, then the same number of molecular orbital also form. So the 1s and 1s, this is then the formation of sigma bond, 1s and 1s. This is the formation of sigma bond. 1s sign positive sign and there is 1s sign positive sign. So when the overlapping, first time we some importance data also be given. Bonding molecular orbital, formed by constructive interference of two wave nature of atomic orbital. Atomic orbital considered as wave nature. Which scientist proposed that the wave nature of the atomic orbital? This is the Schrödinger. Scientist Schrödinger can explain the nature of the electron or any atomic orbital have wave nature of atomic orbital. So the bonding molecular also form the constructive interference. This is the what is the constructive and others is destructive interference. This is the topics of in physics YDSE, Young double slit experiment. This is the constructive interference and the destructive interference are full concept in the physics chapter YDSE experiment. Constructive interference, the two atomic orbitals are always nature of wave nature. The two atomic orbitals are always wave nature according to Schrodinger equation. According to Schrodinger equation. What is the Schrodinger equation? What is the Schrodinger equation? This is the del d square psi plus dx square plus d square psi dy square plus d square psi dz square plus 8 pi square m by h into E minus V into psi is equal to 0. This is the Schrodinger equation. This is the Schrodinger equation. From the formula is del square psi divided by dx square. This is the full formula of Schrodinger equation. This is the Schrodinger equation. The scientist Schrodinger concept the atomic orbital have wave nature. Wave nature, the psi denoted by atomic orbital. The atomic orbital always in wave nature. Then, if two atomic orbital, that means we consider two atomic orbital, one is 1s and another is 1s. This is denoted by psi 1, this is denoted by psi 1. These two atomic orbital are wave nature from according to Schrodinger equation. So, we can consider 1s as a wave nature. 1s or atomic orbital have wave nature. That means this is the wave. This is the positive along the y-axis, positive y-axis along the negative y-axis. This is the wave, this is the psi 1 plus this also same structure due to same orbital 1s atomic orbital. So, this is considered as wave nature from the Schrodinger equation. This is also same shape and same wave plus minus, then two are overlap and formation of molecular orbital. Two are overlap and formation of molecular orbital, that means this is also waveform plus along the y-axis 2 plus, then the resultant plus are increases. So, the graph also increases and resultant negative value also increases. This is the graph, this is the molecular orbital wave function graph plus minus. This is called constructive interference. Two wave are same nature, constructive interference. Two wave are same nature, then they are overlap, formation of new waveform is called molecular orbital wave function. So, this is the procedure of constructive interference. This is the constructive interference. Next, the forming molecular orbital is known as bonding molecular orbital. Previously, you know that the constructive interference formation only bonding molecular orbital. Then, the formation of antibonding molecular orbital. This is the destructive. We consider always, suppose one is atomic orbital denoted psi 1 and another one is psi 2 are overlap. One is always wave function according to Schrodinger equation. This is we consider this is the wave, this is plus, this is the minus. But in one is next another one is consider opposite nature. Then function of the wave function is opposite. This is the wave function. We consider two 1s atomic orbital. One is this graph electron waves, another is opposite electron waves. We consider, then this is the plus, this is the minus, this is the plus of positive y-axis, then this is negative y negative, negative y-axis. Then they are overlap, and formation of plus, minus, minus plus, both are cancelled. The opposite two function, the opposite two wave function are each other cancel, plus, minus, minus plus. So, the nature of the wave is this is the formation of only plane. This is the formation of only plane due to absence of, this is the two opposite nature, 1 plus and 1 minus, this is cancel out, and 1 minus 1 plus, this cancel out. So the only wave function nature is linear formation. This is called nodal plane. This is called nodal plane, and this is called nodal plane, and formation of antibonding molecular orbital, and formation of antibonding MO, and this phenomena is called destructive interference. This phenomena is called destructive interference. This is the called destructive interference. So the two new functions, constructive interference and the destructive interference, are clear. 1s and 1s2 are wave nature from the Schrodinger equation. They are two wave nature are respect with same manner. So they are overlap and formation of plus and plus, both sides same side plus, then the resultant amplitude also increases, and the negative amplitude also increases. This is the bonding molecular orbital electron waves. This phenomenon is called constructive interference. Next, the two atomic orbitals can consider 1s and 1s. Then one is two wave nature are opposite manner. Then they are overlap and formation of only nodal plane. This formation, this molecular orbital formation is called antibonding molecular orbital, which is denoted by star. This antibonding orbital, what is nodal plane? What is nodal plane? Nodal plane, definition of nodal plane: in which plane the probability of electron density is 0. The probability of electron density, almost 0. What is the atomic orbital? Difference between nodal plane and atomic orbital. What is the atomic orbital? What is the atomic orbital? Atomic orbital. In which orbital the probability of electron density maximum. This is called atomic orbital. The difference between atomic orbital and nodal plane. Nodal plane, the electron density, probability of electron density is 0, but atomic orbital have highest electron density probability. This is the basic two difference between the nodal plane and antibonding formation. So the summary today class: the bonding orbital, antibonding molecular orbital, and the overlapping method, the difference between atomic orbital and molecular orbital, what is the limitation of VT or valence bond theory, then the M.O.T theory, explanation for constructive interference and destructive interference, the wave nature of the function according to Schrodinger equation, the mention of the Schrodinger equation, and the difference between atomic orbital and the nodal plane. Next class I discuss about the remaining molecular orbital theory. That means the nodal, how many nodal pole formation for sigma bonding molecular orbital formation, so antibonding molecular orbital formation, how many nodal planar formation, and their distribution of the electron in the M.O.T diagram, which is necessary for CBSE and ICSE class 11 board exam. Very important for M.O.T diagram in a molecular orbital. Next class we discuss the M.O.T remaining theory.